Hello everyone. The title of this video is Solve Quadratic Equations of the form a times x to the second power, or a times x squared equals k, where a and k are just numbers, real numbers, using the square root property. Right. In this video I'll be doing several exercises. These exercises are taken directly from a free online textbook at openstacks.org, and it's their Intermediate Algebra 2nd edition text. I'm in section 9.1, titled Solve Quadratic Equations Using the Square Root Property, and the examples I'm going to be doing are under the heading Solve quadratic equations of the form ax squared equals k using the square root property. I will only be working on the even numbered exercises, so exercise 2, 4, 6, and so on, up until exercise 22 in this video. You will notice that the odd numbered exercises are all highlighted with a link. If you click on the odd numbered exercises, you'll be taken to the solutions. So I'm going to do the ones that don't have solutions. I will also have timestamps for these questions, these examples, in the description of the video. Example 1's timestamp will take you to question 2, example 2's timestamp to question 4, and so on. So you can bounce around to different questions if you wish, whatever order you want. One other request I have is that when I start a new question in the video, pause it and try to work on it yourself first before watching me do it and then comparing. Because if you're just watching me do these questions, without practicing yourself, chances are you're not learning all that much. Alright, so the first question I'm going to do is, exercise 2 here. I've got these written out. Alright, so see example 1, number 2 in the text. Right. And we're asked to solve each equation. That's it, right? You're just trying to find what values can I replace the variable with to make a true statement. And in each of these, we're going to be using something called the square root property. Right, so I'll write that off to the side here. The square root property. And this states the following. If some number squared, so say a squared, is equal to another number b, then a is either the positive square root of b or a is the negative square root of b. Because either one of these, right, the principal square root of b or the positive square root of b, when you square it, gives you b. But also, the negative square root of b, when you square it, also gives you b. Right, remember, every number has two square roots, a non-negative one and a negative one. All right, so this is going to be applied for every single question in this video. All right. So for instance here, right, this equation is already in this form, the beginning, the hypothesis of the square root property. You have something squared equals a number. But notice that the square is isolated, and that's what we're going to do in our equations. Isolate the square, and I'll write that out for question 2. But here the square is isolated, something squared, b squared equals, and then some number on the other side, 144. So by the square root property, which I'll just abbreviate SRP, right, for square root property. So applying the square root property, the SRP, this b, right, the expression being squared, the base on the power of 2, is either the positive square root of 144 or the negative square root of 144. Now remember, the square root of 144 is just 12. So b is either 12 or b is negative 12. And then don't forget to check your solutions, right? We're going to check these. Now, positive 12, when I plug it in for b, 12 squared is 144. Right, so this is a solution. And then when negative 12 is squared, negative 12 times negative 12 is also positive 144. So this is a solution as well. And we're done. Right? The solutions of this equation are positive 12 and negative 12. Great. You could also write, plus or minus 12, right? But I'm going to separate them. Right. Wonderful. Very, very simple, in my opinion. Next question. Right. Example 2, which is exercise 4 from the text. Now, like I said, I want to get my equations to look like this, be in this form from the hypothesis of the square root property. I want the square on its own side equals some number. So notice here, right, t squared is not by itself. The square is not on its own. So that's the first step in all these, is going to be to isolate the square. Alright, so that's easy enough to do here. Just add 75. So I'll take this over here. So we'll have t squared on the left equals, and then positive 75 on the right. And now I apply the square root property. Right? I'm just again writing SRP. By the square root property, then t, the base on the power of 2, must either be the positive square root of 75, or t could be the negative square root of 75. Right, now the square root, now you're also of course going to be asked to simplify your answers. Alright, remember simplifying radicals. The square root of 75 is the square root of 25 times the square root of 3. So that simplifies to 5 times the square root of 3. Right? So t equals 5 times the square root of 3, or t equals negative 5 times the square root of 3. And then you check. Right? Always remember to check your solutions back in the original equation. Well, this is the square root of 75, right? When I square it, I'm going to get 75. That'll definitely be true. And you could put it back here as well, and you'd get 75 minus 75 equals 0. That is true. And then this is also a square root of 75, right? It's the negative square root of 75, but when you square it, you would get 75, and then 75 minus 75 equals 0. Both of these work. Right? Okay, wonderful. And yeah, I'm doing the same thing throughout this entire video. All right, the next question, example 3, which is exercise 6 from the text. We have v squared equals minus 80 equals 0. Isolate that square, right? So v squared equals 80. And then I apply the square root property, right? So SRP. So if v squared is 80, then v is either the square root of 80 or v is, negative square root of 80, or both. It could be, both are solutions. And the square root of 80, 80 is 16 times 5. So this simplifies to 4 times the square root of 5. So v equals positive 4 times the square root of 5, or v equals negative 4 times the square root of 5. And if you check them, both of these are a square root of 80. So if you square both of these, you get 80. So we'd get 80 minus 80 equals 0. That's true for both of these. Right. So they both work. Positive 4 times the square root of 5, and also negative 4 times the square root of 5. Fantastic. All right, question 4, which is exercise 8 from the text. Yet again, I want to isolate the square. See the times 3. That's not good. All right, isolate the square. Get n squared alone. So I divide by 3 and have n squared equals, 48 divided by 3 is 16. And then now that I have the square isolated, I can apply the square root property. Again, SRP. So n is either positive square root of 16 or the negative square root of 16, which is just 4 and negative 4. So n equals positive 4 or n equals negative 4. And if you check those, 4 squared is 16, 3 times 16 is 48, that works. Negative 4, when you square it, is positive 16. 3 times 16 is 48, that also works. Right. Wonderful. So same steps every single time. Alright, so on these last pages here, I have 4 examples, more examples per page, because you saw how quick and easy these can be. So example 5, exercise 10 from the text. Get the y squared alone first. Right, but I would multiply by 3 to get 180, then divide by 5 to get 36. Right, or just multiply both sides by 3/5, right, to get rid of the 5/3. And 60 times 3/5 would be 36. Right, and then I apply this. Now that I've got the square alone, I apply the square root property. Y is either equal to positive square root of 36 or negative square root of 36, meaning 6 or negative 6. Y equals 6 or y equals negative 6, and check them. Well, 6 squared is 36. 3 goes into 36 12 times. 5 times 12 is 60. This works. And so would negative 6, because negative 6 squared is also positive 36, and 5/3 times 36 is 60. Great. 6 and negative 6. Alright, example 6, which is exercise 12 from the text. Alright, so here I have y squared plus 64 equals 0. Get the square alone. Alright, get the square alone. Y squared equals, negative 64. And then, the square root property still applies. Alright, so y is either positive square root of negative 64, or y is, the negative square root of negative 64. Alright, now here's the difference between, questions 1 through 5 and question 6 here. Here we have the square root of a negative number. Now I hope you remember how to simplify these, right? This was done in previous videos. The square root of a negative number, we're going to rewrite with that imaginary unit I, right? Don't forget I, right? The square root of negative 1. So this is rewritten as the square root of positive 64 times I, which is just 8i. All right, so y equals 8i, or y equals negative 8i. And then check them. Now when you square 8i, that'd be 64i squared. And just remember that I squared is negative 1. So that'd be negative 64 plus 64 equals 0. This works. And the same thing happens with negative 8i. When you square this, it'd be 64i squared, which is negative 64 plus 64 is 0. They both work. So y equals 8i and also negative 8i are solutions. Right, so we are going to have some solutions that have an imaginary number in them now. Alright, then question 7. Very similar to 6. It's exercise 14 from the text. Get the square alone. So y squared equals negative 45. And then I'm applying the square root property. So y is either positive square root of negative 45, or y is the negative square root of negative 45. And I'm again seeing the square root of a negative number. So these will be rewritten as an imaginary number, right, with that I. Y equals the square root of 45 times I. And the square root of 45 is 3 times the square root of 5, right? The square root of 9 times the square root of 5. That's the square root of 45 simplified. But then don't forget the times I after that, right? Multiplied by I, the imaginary unit. Or y equals negative 3 times the square root of 5 times I. Just make sure the I is not in the square root. Right? And if you were to check these, both of these are square roots of negative 45. That means if you square either one of these, you're going to get negative 45 back, and then negative 45 plus 45 is 0. That is true. So both of these make the original statement true. Right? 3 times the square root of 5 times I, and negative 3 times the square root of 5 times I are both solutions. Okay. Next example, 8, which is exercise 16 from the text. So first I would add 8, and we'd have 2/3 y squared equals, negative 2 plus 8 is 6. And again, I want to isolate the square. So let's get rid of the 2/3. Divide by 2/3 or multiply by 3/2. Right? If you multiply by 3/2, 1.5, you get y squared equals 9. All right, and then I apply the square root property. Now I'm just going to do this right now. Y equals, the positive square root of 9, which is 3. All right, 3 squared is 9. Or y equals negative square root of 9, which is negative 3. And check them. If you square either one of these numbers, it's giving you 9. And 2/3 times 9 is 6, minus 8 is negative 2, so both of these work. 3 and negative 3 both work. Great. Alright, so I got one final page here with 3 more examples where I'm doing the same thing every single time. So I wish to, for number 9, which is exercise 18 from the text, isolate the b squared. So I add 7 first, and we get 3/2 times b squared equals 41 plus 7 is 48. And then I divide by 3/2 or multiply by 2/3. Now 2/3 times 48 is 32. So b squared equals 32. Right, 3 goes into 48 16 times. Times 2 would be 32, right? Okay, now if b squared is 32, I have the square alone. I can use the square root property. Say that b is either positive now the square root of 32 simplifies to 4 times the square root of 2, right? The square root of 16 times the square root of 2. Or b equals, negative 4 times the square root of 2. Right. And if you check them, they both work, because if you square either one of these numbers, it's going to give you 32 back. 3 halves times 32 is 48, and 48 minus 7 is 41. Right. So both of these work. Wonderful. All right, next question. All right. Example 10, which is exercise 20 in the text. So first I'd subtract 5. We have 2q squared equals 25. And then divide by 2. So q squared equals 25 halves. Right? This does not simplify any further than that. But now I have the square alone. So that means we can apply the square root property. I'm going to do this over here. Say we're applying the SRP. So q is either positive square root of 25 halves, or q equals negative square root of 25 halves. Alright, now you may recall that this isn't considered simplified in this text. Right? A simplified radical can't have a denominator in the radical. So let's do this off to the side here. Alright, the square root of 25 halves, I'm just going to do it on a different piece of paper. So the square root of 25 halves, right, I've got a denominator and a radical. That's not good. So I break it up, right, using the quotient property for radicals. This is the square root of 25 divided by the square root of 2, which is 5, square root of 25 is 5 divided by the square root of 2. And then I would rationalize the denominator, right? Multiply the numerator and denominator by the square root of 2. And we're left with what they're really asking for here with the simplified results. We'd have 5 times the square root of 2 in the numerator divided by, and then 2 in the denominator. This is what I'm going to put in instead of the square root of 25 halves. So we have q equals positive 5 times the square root of 2 divided by 2. Or q equals, the opposite of that, negative 5 times the square root of 2 divided by 2. Right. And if you check them, right, either one of these numbers, when you square, gives you 25 halves. And 2 times 25 halves would be 25, plus 5 is 30, so both of these work. Wonderful. All right. And finally, question 11, which is exercise 22 from the text. Same stuff. All right. First, I'm going to get this square alone. Let's add 8. Get 3x squared equals 54. All right, 46 plus 8. Yeah, 54. And then dividing by 3 gives me 18? 3 times 18 is 54. Good. So x squared equals 18. And then I can apply the square root property now that I have my square all by itself. So x is either the positive square root of 18, which is 3 times the square root of 2. Right, square root of 18 is the square root of 9 times the square root of 2, 3 times the square root of 2, or x equals negative 3 times the square root of 2. Right? And either one of these numbers, when you square them, gives you 18. So we'd have 3 times 18, which is 54, minus 8 is 46. So both make the original statement true, both are good. Fantastic. So yeah, so these were all pretty simple examples. In every single one of the examples for this particular video, see how there was a variable in a square and then there were no variables outside that square. Alright, same thing here. B was squared and there was no B outside that square. Here Q was squared and there was no Q anywhere else. So if you see that, if you have quadratic equations like that, where there's a variable in a square and no variables outside that square, well, then you can very easily solve with the square root property. Right? You isolate the square and then apply the square root property and solve for your variable. And of course, check your solutions at the end. Wonderful. All right, so I'm hoping that watching me go through these 11 questions here, 11 examples, help you in some way when you're asked to solve quadratic equations, of these particular forms, right, where there's a variable squared and no variable outside that square. When you're asked to do that using the square root property on your own, I hope I help you a little bit. And thank you very much for watching.